Hello everyone and welcome to Handmade Hero, show where we code a complete game live on stream. Before we get started today, I wanted to mention that we have created a Discord for Molly Rocket, which can be used for Handmade Hero and things related. And so I just wanted to point out that that's available now for your use. It's open and you can join it. The address, if you want to type it in, and we'll probably provide links to it, there's actually on the Twitch page itself, there's an ask a question via Discord button that would get you there, but it's really just the standard discord.gg link. If you just put in Molly Rocket, that will go directly to our section of Discord. There's already a lot of people on there, so please go ahead and join. We do, unlike Twitch chat or other places that are kind of a little more Wild Westy, this is actually monitored by us at fairly regular intervals. And we do maintain some pretty strict rules on there. So basically, there's no politics allowed whatsoever and no outrage allowed whatsoever. So it has to remain civil discourse and completely apolitical, or I will happily ban people all the time. So keep that in mind, but anything that you would normally use the Twitch chat for on Handmade Hero, like asking me a question, can be done there. And there's even a special Pound Live channel you can go to that I'll keep up during the streams that I can read. So that's a great place to just ask questions if you're tired of trying to use the Twitch chat, which I realize can be kind of annoying sometimes. All right, that's it for announcements. Let's actually talk about the show. What are we going to do today? So we kind of left off last time with getting our situation squared away for communicating with the 3D hardware a little bit more cleanly. And we actually learned something really valuable now that we got both RenderDoc at the end of the show, actually, and Nsight working. And it turns out that both of them are now working very well. Originally, when we tried RenderDoc multiple years ago, I think like a long time ago, it wasn't able to actually work with the graphic setup that we have, but it is able to work now, and it's pretty good. So actually we can use either one of those tools, and maybe we'll try using RenderDoc a little bit more now, because RenderDoc I believe works across multiple configurations, so it might be a little bit more applicable to folks out there who are following along at home, because you don't need to be using an NVIDIA card specifically in order to use it. I think Nsight just won't work on like an AMD card, for example, for obvious reasons. NVIDIA is not exactly in the business of providing debugging tools for other people's hardware, right? But RenderDoc is designed to be a sort of more general purpose cross-platform debugging tool for graphics, and so we might try to use that a little bit more, assuming we don't hit any like snags with it, obviously. So anyway, we found out something really interesting actually when using it, which I'll recap now, which is that actually the slowest part of our frame render time at the moment, if we turn off some of the inefficient things, like right now we don't have very efficient ways of sending down ground cover, but if we assume that we were to speed that up using some fairly obvious ways we would do that, one of the things that we see is that actually we do spend quite a lot of time in our multi-sample resolves, like a lot of time in our multi-sample resolves. So much time, in fact, that without ground cover, it massively dominates the runtime of our game doing those multi-sample resolves. Now, will that change as we turn the ground cover back on, add particle systems, generally stress the renderer more? Absolutely, because the multi-sample resolve costs the same amount no matter how much we draw to the screen. And so it does stand to reason, and obviously makes perfect sense, that as we scale up the graphics for the game, the amount of time that we spend in our multi-sample resolve will go down proportionally, because the rest of the time for the rendering is going to increase, whereas the multi-sample resolve time will be the same as it is right now. However, that said, what we do also know is that that time is not insignificant. And so it may be something that we want to think through, because there probably are ways that we can restructure how we're doing our rendering such that we don't really need that kind of detail on the multi-sample resolve. And the reason that I say that is because the only thing we actually use multi-sample resolve for is cleaning up the edges of our like geometric primitives. So when we put sprites on the screen, for example, we don't actually care even a little bit. When we put sprites on the screen, we don't have any need to know what's happening in the multi-sample buffer, right? Those could be done completely separately. If we didn't have geometric primitives that have actual hard lines in them, we would not have to actually use multi-sampling at all. So our sprites don't rely on the multi-sample buffer to get high quality. We've gotten high quality just by being careful about how we draw our sprites. So it's worth noting that the multi-sample buffer is just there because we're trying to smooth out those lines that are on the edges of our geometric primitives. Now, those geometric primitives are essential to the game, certainly, but we may be able to figure out a way to draw them such that we don't require multi-sampling to be on for the rest of the cycle, right? For example, the depth peeling that we use to make sure that we can do order-independent transparency, we could just say that we don't want to do that for all of our geometric primitives because they won't need it since they're solid and don't have transparency, right? And so if we, a priori just said that pass that involves the geometric primitives themselves, that pass is the only one that actually has to go through the multi-sample buffer, well, that's a pretty compelling argument just in terms of how we might go about speeding up this process. So let me show you okay, that's not what I meant to do. Let me show you what I mean by this, and that may be what we do today, is just get that one last little thing done before we put the lighting in, because the lighting is going to add a bunch of stress to the system, and I'd like to have the system working well without that. So this, and maybe the other thing we could do on Sunday, again in preparation for adding the lighting stress on, is we could clean up our ground cover submission process. So again, we could maybe take some of the load off there. So there's things we can do to improve the way our rendering is working right now, and I just like to get those out of the way, and then when we start to add the stress of lighting, at least then we're only fighting that one thing at a time. So this is render doc, and what I'm going to do here is going to go to launch application. I'm going to do load, well actually I guess it's already in here in my last settings. I'm going to do load last settings here, and you can see I didn't have the working directory set properly. That's one of the reasons we were getting crashes in it before. I'm going to go ahead and make sure I set this working directory correctly, and that's what we need to be set to now. So I'm going to save those settings into this render doc, handmade render doc cap thing here. I think that's how it's supposed to go. Let's just say that it is. I don't really know. There we go. And let me do load last settings and see. Nope. Okay. So clearly that's not how that works. I'm not sure how that actually works then. Okay, there it is. Nope. Maybe I have to just do this. Close it? I don't know how to get it to remember that. No idea. Maybe those are stored in some other file or something. But I don't know. For the time being, I'll do it this way because that's what seems to work. So anyway, if we run the game from here, you can see me doing it. Here is the game running, and you can see the ground cover is turned off, as I said. As I hop around, you can see the game running as normal with some debug points in there for where the lighting probes are at the moment. If I hit the F12 key, it will do a frame capture. I can then look at that frame capture. If I close the application, because I don't really need it running anymore, we can just pop back here, and what you can see is this is the capture of one single frame. You can see it drawing the color passes here, and it's actually a little bit easier, in my opinion, to use than Nsight for that purpose, because here's, you can kind of see me just quickly going through and seeing what got rendered in those different passes. It's a little zippier. I don't know. It feels a little bit easier to use personally. Just personal preference probably there. But anyway, what you can kind of see about this in general is that if I want to, I can go to this clock, right? And you can see the clock timings that are really not correct. I don't really know to what extent these can be relied on, but there's some kind of approximation to how much time is being spent. And they do agree with the Insight ones, at least in terms of ref proportion. What you can see here is something like this, where I get the color pass, which is a clear plus a draw elements, and then another draw elements, right? You can see that that entire thing, which drew all of this, that whole thing took only on the order of 331 microseconds. But here you can see that this single resolve, that's just one full screen quad running the multi-sample resolve shader, that took 3 milliseconds. So it basically took 10 times as long to resolve the multi-sample buffer as it did to draw the buffer in the first place. So that shader code that we're executing there, and more importantly probably than the shader code, although who's to say, but more important than the shader code, the bandwidth of pulling the entire multi-sample buffer in, the whole thing, maybe really cost us a lot. And the reason that I say that it maybe is because I don't really know what the graphics card is doing, but just to give you some perspective, the reason a multi-sample buffer is a multi-sample buffer is because the graphics card itself is allowed to optimize how it chooses to allocate those samples. So for example, if it wanted to, it could keep just a regular color buffer for the multi-sample buffer, along with a flag that says whether it needs to actually have any multi-samples, right? And then have a backing buffer for the other 15 multi-samples if a particular pixel needs them, right? It could just implement it that way. There's no rules about how the graphics card treats a multi-sample buffer. So what that means is for 90% of the pixels on the screen, like you can see here, most of them would not need to ever touch the deep part of the multi-sample buffer. It's just one color written by one triangle that covers the entire pixel, right? And so the only pixels that actually need to talk to the multi-sample part of the multi-sample buffer are the ones that actually lie along the line of a geometric primitive, such as right here. And that is drastically fewer pixels than the entire multi-sample buffer. Unfortunately, as far as I know, and I even asked this on Twitter to see if anyone out there who's a GPU expert maybe had heard of something or knew anything about it, I even asked them, is there any way inside a standard kind of shader to ask the graphics card on a particular pixel while doing a resolve, is this thing completely covered by one color or not? And if we could do that, then we would be able to put in a warp branch kind of inside our shader that would probably optimize it quite a bit, that just said, if there's only one color, don't read the other 15 multi-samples, right? Because all of that extra bandwidth of reading all of those extra samples, if in fact the graphics card has optimized them, which this number suggests to me that they have, the fact that it's so much lower. Because remember, it had to touch all the pixels, right? It had to read and write the entire multi-sample buffer, just like this has to read the entire multi-sample buffer, right? This had to do all of that. But the fact that this was able to do it so much faster than ours, unless it's just because our shader is super crappy or something, which it could be, but the fact that it could do it that much faster suggests to me that it was probably hitting a fast path where most of the time it didn't actually incur the memory bandwidth cost, right? That's what that suggests to me. Now again, I don't know if I'm right because I don't have any way of really interrogating the graphics card in any way that could tell me. But that seems to me to be a likely candidate, right? So what that tells me is that if we could, right, the best possible case for us would be if we could do something where the multi-sample resolve that we're doing like here could be done in such a way as to not require the depth peeling so that we don't have to do it 4 times, right? That would be the best possible case for us. Now, the problem with that is that right now we sort of do use the depth peel to handle something that involves the geometric primitive. That something is when we have two floors stacked on top of each other and we alpha the top floor out. We are currently not guaranteeing that we draw that in any particular order. We just draw it in any old order that happens to come in, and we don't ensure that floors that are higher up, for example, get drawn before floors that are lower down. And so we do currently have, unfortunately, a restriction that doesn't really let us do anything intelligent there, right? So now the question is there something else that we could do? Like, is there something we could do that would allow us to do this result, or to get that like anti-aliasing that we're trying to get there? Is there some way we could get that anti-aliasing in a way that allows us to drop the number of these resolves down to just one? So we only pay, you know, this like 2 millisecond cost here or something, but don't have to pay the 2 to 3 millisecond cost 3 more times up here in these other resolves for no reason. That's the question. And the answer is probably yes. But I'm not sure I necessarily know why. So I have to kind of think it through. Let's pop over the whiteboard, or blackboard as the case may be, and see what we can figure out. Also, while I'm at it, does anyone know if Milton ever got fixed to fix the bug that they introduced with the fact that the smoothing looks really bad now? Does anyone know? I'm not sure, like, if that ever got, you know, because we got this nice like grid feature in there that someone added, but in order to get the grid feature, we had to upgrade to a new version, and that version seems to have a weird like bug where the smoothing's all messed up. It's very like rough now and has a lot of weird like small errors and stuff like that. I'm not sure. So it would be interesting to know if anyone ever figured out what was going on there. I would certainly like to know and perhaps upgrade to a new version if anyone knows the answer to that question. So let me know in the Discord or something if that's the case, because it would be nice to get that sorted out at some point in the near future. Okay, so here's the problem that we currently have. We have our sprites, and our sprites are like A-OK, right? These don't need multisample at all. But these do, so they don't need multisample, they do need depth peel. Then we have our geometry. And these do need multisample. And sort of need depth peel. And so what do I mean by that, right? What do I mean by sort of need depth peel? Well, like I said, sometimes we may want to use the ability to alpha blend floors in and out. And so they kind of do sort of need depth peel to a certain extent. But what does that really mean? Do we really need depth peel necessarily? Like, is that actually something that we really need to have? Or is it not so necessary, right? Because remember, the reason that we needed the depth peeling on our sprites is because we want to be able to draw all of our sprites with no sorting and just have the Z buffer figure it out. And in order to do that and have the alpha values still composite properly on top of each other for partial alpha values, we need to know what order they come in, and the depth peel is really the only way to do that, right? But my question here is, well, for alpha blending, do we really need to, like for when we're doing one floor on top of each other, that's not really as hard of a problem as just a crazy crap ton of sprites just thrown together and expecting the graphics card to sort them out, where depth peeling was maybe a little bit more warranted. if we're just talking about alpha blending out at a certain range that's, like a fogging distance to us, that seems like something that we might be able to handle in a different sort of way. And let me sort of say something else about that while we're at it. If I was to run the game here again, let me go up into, well, actually, let me just run it as I normally would in Remedy. So let's launch the debugger here. Let me go to loading. There we go. So if I was to run it here, what you would notice is that as I do start to use that feature of alpha blending out a floor that's on top of the floor that we're currently on, what you'll see as I go down these stairs is that as I get lower down into, and the camera starts to move down, is that the alpha blending, when I blend these out, does some somewhat undesirable things, actually. I hope you can see there is, like, when I blend out that floor, I actually sort of cut away the floor, and I can see, like, the inside of the cubes, right? Now, we may decide that that's fine. Like, maybe that effect is just kind of nice, and we don't, like, maybe it's just a nice, smooth effect, right? So there is something to be said for that. But at the same time, there is a separate issue there, which is like, well, if I really wanted this to work more artistically, we probably wouldn't alpha blend out the floor that way. What we would do instead is we would alpha blend out like this rendered image, in a sense, and we wouldn't allow you to see like the backs of cubes or something in there, right? And no matter what we do, if we just use the alpha the way we're using it now, you're definitely going to see those, because even if we turned on some kind of a backface call that would remove these interior facing polygons here, which we certainly could do, we would still end up in a situation where these cubes here, we would see their sides, which we were not previously able to see. And so there is a certain amount of, like, me looking at that going, well, I don't know about this, right? And so when I think about that, what that strikes me is, if I was going to, like, play around with this a little bit, that strikes me as something where I may want to say, well, 4 multi-samples, we can do better than that. 4 multi-sample resolves, we can definitely do better than that. 2 multi-sample resolves, I don't know, 2 multi-sample resolves might be necessary. And the reason I say it might be necessary is because what I might want to do is just do 2 depth peels of the geometry, one for things that are past the alpha plane and ones that are for things that are before it. And then blend those out in a cleaner way that doesn't involve that kind of sort of seeing how the sausage is made might be a bad way to say it, but you know what I mean, right? Like seeing an element of geometry that really has nothing to do with the artistic intent of the game. It was just something that happened because these things happen to be drawn as cubes. And we happen to be setting their alpha value down, but no one really wanted it to look like a hollow box there. We just kind of wanted the floor itself to sort of fade out, and then instead we got this, right? So the question is, like, can we do something with that? Is there some way that we can maybe play around with that? And so what I would say is, if we just assume here that we take the sprites and we were to say, let's do these in a separate pass, right? So there's a separate pass that deals with sprites, and that pass is going to be somehow, removed from a pass that involves geometry, and perhaps the geometry, for example, is just rendered into a temporary buffer that gets composited in with the sprites during that depth peel process, as if it was just another sprite, a sprite that happens to be the full screen or something, right? And so if you imagine doing it that way, what you could imagine doing is just taking the geometry, rendering out the geometry in the multisample buffer, resolving the multisample buffer to a full screen quad, and then when we actually do our sprite resolves, we just mix it in as one full screen quad pass. That means that the depth peels themselves never need to go through a multisample resolve. They can just be used as is with multisampling turned off. And then the geometry part, which does need the multisampling, well, we'll turn it on for just the part that computes the geometry pass, which is then composited in as if it was a full screen sprite with its own depth buffer, right? So that's a relatively easy way that we could do that process, and I think that would work just fine. The only thing that it doesn't do, again, is handle alpha blending out those floors that were too close to us. And so that's the part where I say we may have to do a 2x of the multisample resolve. The reason I say we might need to do a 2x is because when we're actually doing the rendering, and we do that multisample rendering, it seems like something where, I don't know, even if we're doing 16x multisampling, if we do a screen door transparency kind of thing for the blend outs on those things, I think maybe that wouldn't quite be smooth enough. I mean, I don't know, right? So maybe it would be fine, and then you could just get away with one. But I just don't know. And so to get the full, 8-bit at least interpolation of that fade, what we would have to do, I think, unless I'm missing something when I'm thinking about it in my head here, I may be missing some other way of massaging the problem. But what I'm thinking about is we need to introduce a plane that's like, here's the alpha cutting plane, right? Everything behind it gets generated in one pass through the multisample buffer, which we then resolve. And then everything in front of it gets generated into a separate buffer and then resolved, right? And then those two get alphaed on top of each other based on depth, right? And I can't really say that I know what else I would do. And yeah, so if we wanted to do it in just one multisample pass, then what we would presumably do is we would just yeah, I mean, I'm sorry, but I can't really think of any way to do it in one multisample pass other than just using screen door transparency for things on top. And the reason that doesn't really thrill me either is because if you think about what that's going to do, doing screen door transparency, and especially when you got like a whole floor that's getting blended in on top like that, that means for that whole screen, basically, like the whole screen, because most of it's going to be filled with that upper floor that's in your face, that whole thing is going to have to touch a large amount of the multisample buffer, because the screen door transparency algorithm that would be used there would be to say, look, what's the alpha supposed to be? Let me cover that many of the 16 samples with my coverage information, and that would again put it on the slow path for multisample, meaning as we go in to write a pixel, it's going to have to write to all 14, 15 multisamples, sometimes even 16 if it's opaque there, right? So that doesn't seem good either. And so just, I don't know, I'm not thinking of a way to be able to blend those floors in and out without two multisample resolves, one to resolve the underlying floor geometry and one to resolve the geometry in the upper area, right? I can't really think of anything else we can do there. So that's the best I think I can do. I don't really think there's much else. I don't really think there's much else in the way of options. So I'm going to go ahead and assume, and this assumption may be very incorrect, but I'm going to go ahead and assume that we need to use at least 2 multi-sample resolves to get high quality results there and support all the features we want to support. I may be wrong about that, and if I am, then maybe we can figure out if someone has suggestions about how we would get that number down from 2 to 1. But either way, going from 4 to 2 still basically is a speed doubling, right? 4 multi-sample resolves cost twice as much as 2 multi-sample resolves, so it's still, even just doing this one refinement, would potentially save a lot of would potentially save us a lot of issues, right? So I think we probably want to do that. And the only thing that's a little bit tricky about it is it does mean that we have a little bit harder work to do in terms of how our geometry gets segregated into sets. So if you look at what's happening right now, we have a geometry buffer and we fill that geometry buffer up with geometry and then we render it. And the nice thing about that is that, at least so far, we haven't really had to think about much in terms of what's going in there, other than the fact that the game is bracketed by 2 markers that say everything inside here goes through 4 depth peels, whereas the part that comes after it basically, I think, says, look, you don't have to, because it's like a debug HUD overlay or something. So there's a little bit of optimization inserted with respect to that. But in terms of the actual game, like the stuff that gets outputted for the game image, there's nothing in there in terms of like logic, right? It's just a render buffer that just has a bunch of quads in it. Some of those quads represent sprites, as some of those quads represent geometry, but we don't actually do any work to keep those 2 things separate, and so the render itself doesn't really know which ones are which. And more importantly, they're not batched up in any way that would be conducive necessarily to making sure that we can render them quickly. Because, for example, if geometry and sprites want to be rendered separately, we would like all of the geometry to be in one batch and all of the sprites to be in another batch or something thereabouts. And currently the way that we record our render information is we put geometry and sprites into the same buffer. So we don't actually know at any given time which one of the 2 we were using. And even if we marked them, so we said these ones are geometry, these ones are sprites, they would still be interleaved in a way that is very inconvenient for us to do it in a single batch, because a batch wants to take a contiguous range of things, whereas we may have cases where we're just doing like a cube and then a sprite and then a 2 cubes and then 2 sprites and 3 sprites and then a cube, right? And each one of those things, if we were actually doing some kind of a split render to different render targets, would incur a render target switch, and we would just slow things down to a crawl. So we definitely don't want to do that, which means that the one thing we would have to do to improve this process, if we did want to stop depth peeling our geometry and go a slightly different direction with it, is we would have to start segregating sprites and geometry into 2 separate buffers, so that when you actually push a sprite onto the render buffer, it goes into one channel, and when you push a cube on, those quads go into a different channel, and that way they stack up into separate buffers and remain contiguous the entire time, which isn't particularly hard to do, but it does introduce a little bit more overhead in terms of us, during setup, having to create multiple buffers that we fill with differing information, basically, right? So I'm not really sure, again, just thinking that through, it seems like the right thing to do to make that change. But the reason I'm talking it through extensively and a little bit hesitant is it does sort of start to degeneralize the renderer a little bit, right? Right now, there's not that much stuff in our renderer that's super specific to Handmade Hero, right? Really, anything could sort of be dumped in there that's a game built out of quads, and there's not a lot of stuff you have to worry about in that regard. But this would definitely make a difference. It would basically say, we do need you to think about what things you have that have alpha and which things don't, and we do need those things to be segregated at the head end, right? So when they get fed to the renderer, they have to go into separate buffers at output time and you've got to keep that under control, right? So that's the only thing that gives me some pause. I apologize for the yawning. I'm kind of tired today. It's normally I do this in the morning. We're doing it at night. So that's really the thing that gives me some pause. Not the good kind of pause like a cat has, but the bad kind of pause, like when you're not sure if it's the right decision. But it does give me some pause because I'm like, well, all right, maybe the right answer there is to just not go that extra mile, leave it going the way that we're going now because it's a little bit more general. And look, you just turn off multi-sampling if you're on a lower end graphics card, and you get some crispy edges on our geometry, and that's just how life is for you, right? Excuse me. So that's certainly possible. Let's think about what else so let me just brainstorm a little bit and think to myself, what if we wanted to turn off multi-sampling entirely? Like, is there anything I could do that would allow me to just not have this problem at all? You know what I mean? My guess is the answer there is no, of course. But, what's the options? Right? And so there are some things that, maybe we maybe we do have going for us. I'm trying to think. But, like, for example, one of the things we know is that we could produce a multi-sample buffer entirely separately if we wanted to, right? We could render a pass that just produces a multi-sample buffer. It doesn't do anything else. It's basically just a multi-sample depth buffer or something. I mean, I don't know exactly, but it's just, some kind of multi-sample buffer. And so we could produce the edge information as a separate piece of information, right? I mean, we could do that if we wanted to. And so, that would work, right? Like, if you look at what's going on here, and you want to look at, like, where we're getting, this sort of effect. So if you look in here, you can see how nice and smooth that edge is. That's what the multi-sampling is giving us right there, that particular edge, right? So like edges like in there, has nothing to do with because that's inside the texture, so it's bilinear filtering that's keeping all of that working properly, and mip mapping and so on. That's what's keeping the results high quality all inside there. But anytime you see the edge of a primitive, that's the multi-sampling in action there, where it's basically getting those nice smooth edge effects, right? Where those things meet, because it's allowing it to record who's getting covered in which cases, right? And so that's really the thing that we're trying to recover. And the problem is, I could produce that edge information in a separate pass that would only really need one pass and wouldn't have to be depth peeled at all. I could produce the information of where the edges actually are. Unfortunately, I don't think there's anything I can do with that information. So, yeah. I mean, just thinking it through, I just don't see what I would be able to do, even if I read from a buffer that gave me that information. The problem is, if you think about how this thing is rasterized, I don't really know. I mean, I don't know to what extent I can turn on something like conservative rasterization. And just to give you some perspective on what that is, if you look at one of these lines that is drawn like this, what multi-sampling requires is that you effectively have conservative rasterization, or rasterization that considers pixels that are mostly outside the primitive but still slightly inside. So you can kind of see in here, this pixel right here is mostly inside the primitive. And of course, it gets assigned a correspondingly high alpha value as a result. So you can see, this part here that's being drawn on top of the floor, it's blending in mostly this and only a little bit of the floor, right? And so if you look at what's actually happening, this is mostly inside. Most of the pixel is covered by the primitive. And as we get further up, less and less of the pixel's getting covered. What that means is that if you looked at a pixel that was like this one, where you can see that almost none of it is probably covered. So it's just at the very edge, right? So only maybe just the little corner of this pixel was actually covered by this primitive over here. If you think about what's going on there, when you actually switch away from multisample rendering, you're never going to call the pixel shader on this actual pixel, because it's not having its center covered by the primitive. And so to the extent that I could turn on conservative rasterization, right? Meaning if I could tell the graphics card, which I've never tried to do before, but if I could tell the graphics card, look, anytime you would have covered one of the 16 multisamples in a multisample pattern, I need you to actually invoke my pixel shader, even though there is no multisample target bound, right? If you imagined doing that, then in theory what you could do is you could say, well, if I run a multisample, then I look at the resolve of the multisample, and I store out which primitive was the one that was the high coverage and which primitive was the low coverage and what their blend ratio was. Then what I could do is something where I just take the color and I say, whatever I would have written to this pixel, if I'm the high primitive, I write it in as the term that matches that amount of blending into the pixel. And then if I'm the low one, I do the inverse of that, right? And that recovers this blend for me without actually ever having the multisample there at all anymore, right? So what that would allow me to do is render one pass into the multisample buffer, resolve the multisample buffer into what is basically an edge smoothing buffer, and then when I render, do the blend without actually having to have multisampling on at all, right? I mean, it sounds like something that probably wouldn't work, and the reason is because I don't know how widely supported. There is a thing called conservative rasterization that probably would do what we need to do there, but I don't know how well supported that is. Like, I could do a brief search for it, but I'm not super confident that we would want to be using something like that as a core aspect of how we do our anti-aliasing, right? Like, that just sounds like maybe not such a good idea for a number of reasons, right? So I don't know. I'm pretty apprehensive about that. And now that I think about it, another way of looking at this problem is that if we turned on, I think I mentioned this too back when we originally did it, if we turned on conservative rasterization, because we're currently, like we are, as we speak, we are already doing a depth peel. The depth peel would handle the multisampling for us. So because it's already going to blend things on top of each other according to their coverage alpha values, all you have to do is just write the coverage value into that pixel. So I want to almost say that all the crap that I just said actually isn't necessary at all. All we really would need the thing to do is to do the conservative rasterization and then give us back that value. Like we just need to know how much of this pixel was covered. Just give me a number between 0 and 255, right? We just need a coverage to alpha. So let's see if we can do that, right? Because if we could do that, multi-sample resolve is gone. We just don't need it, and we'd still get perfect anti-aliasing. If we could actually get it to do that. I'm going to give it one more shot. And I feel like I already looked for this, so I'm a little bit apprehensive about it. But I'm going to give it a shot. Oh, great, because it's apparently patented. Always good to know. Probably not what we're doing, but, you know. Gotta love those patents. So again, this is kind of nice separately, even if this is not something that we can actually end up using. But if you kind of look in here, this is exactly what I was just trying to say. So this is an example of a primitive, and you can see how this pixel is almost entirely outside, right, of the primitive that's being rasterized. Nonetheless, because conservative rasterization has been turned on, it still gets covered, right? And that's what conservative rasterization means. It means let's include more pixels than we actually would need to, so we're not being like aggressive, right? And so, that is precisely what I want to turn on. And so, at least we know somebody, oops, did I? There we go. At least we know somebody would allow us to do this, right? It looks like, maybe these are some old links. All right. So this is how it would be done in D3D. We could look in OpenGL. So here it is. So there's this conservative raster call, right? And this conservative raster call would probably be all we would really need to do to get started, right? So let's see here. So I'm not sure exactly. We'd have to look at how to set these up properly because there's a little bit more to it than that. I'd have to read exactly what those equations were. But, point being, it's all kind of what I would expect to see in here. Yeah, so we would just enable this. We would set some bias information as necessary. And then the only question is, inside the shader, how do we know how much coverage we would actually have? Yeah, so I don't see. I don't see any information you can actually use to know how much you've covered, like what the actual coverage is there. So that's a little bit rough, and I don't know. So you can see here it's talking a little bit about, I'm going to read this and see exactly what it's talking about here, but it says, OpenGL runs a fragment shader once for each pixel covered by a primitive being rasterized. When using multisampling, the outputs of the fragment shader broadcast, right, what we expect. And we can also run the fragment shader once per color sample if we want to actually do it. And then it looks like you can also do some sort of nonsense here where you control that a little bit more. We don't really care much about this. I just want to know if there's something that gets passed to the shader, right? So you can see here, they are talking a lot about stuff that interacts with the shader, but I still don't see anywhere where it actually gets passed, right? You know what I'm saying? So what about this? Again, still not seeing anything about the shader per se, right? All I really want to know is what the coverage is. This is actually something that we would call, which we don't actually want, right? And we don't want alpha to coverage. We want the opposite. We want coverage to alpha, right? We want to take however much of the pixel was covered, and we want to get that as a value. But again, just not seeing it. Oh, hey, look, it's the witness. So I'm not sure. I am not sure what to make of that. Let's see what this has to say. So these are some built-in uniforms. GL num samples is sort of saying how many samples were covered there. What is this? Set modifies the fragment alpha and coverage values based on the values of sample alpha to coverage, sample alpha to 1, sample coverage value, sample coverage invert. Again, I just want you to tell me how many would be covered if we were multisampling. I don't want to actually have to turn on multisampling. Right? And again, I don't really see much. Like GL sample mask, again, would just be, I assume only set if we were actually in, uh, a multisample buffer. And I'm assuming that in something like, the conservative rasterization, they're not going to set those pieces of information, but well, this is kind of a bummer, right? Like, I really only just want just this, and I just want to know how much was covered. And I mean, I could, if I was really gonna get ridiculous about it, I could just pass down the edge functions myself and try to compute the coverage directly by intersecting them with the pixel area. But I don't really need to do that or want to do that anymore. Like, I really just need to run the multi-sample code and get that value back, right? I mean, maybe it is better to do it analytically. In which case, yeah, what I'd have to do is send those 4 edge functions down for every quad or whatever, right? You'd just send down the 4 edge functions. You would intersect those edge functions and see how much of the pixel itself was actually covered. And I mean, technically, it's really only 2 edge functions, because for any triangle that's in actual geometry, the only 2 edge functions you need are the 2 that don't share an edge with the other triangle of the quad. They're not making this one easy on me, are they? They are not making this one easy on me at all. But in some sense, I could at least turn on conservative raster, and then in theory, I could compute the value myself. But it's a real bummer. Let's see what we've got in terms of coverage for that anyway. Like, is this even an avenue worth pursuing or not? Let me see here. Extensions. Search. Conservative. Raster. Hello? That seems like less. Okay, there we go. So if we take a look at what's going on here, you can see there's not a lot of goodness here, right? Like, the number of people who could actually benefit from using GLNV conservative raster, not great, right? So it does seem like we're still kind of SOL on that. Which leads me to ask sort of a related question, which is there any way to run the hardware in multi-sample mode without actually having a multi-sample buffer, right? Here we go. I mean, fundamentally speaking, that's all I actually really need. I don't need conservative rasterization. I'm fine with only 16 grayscale levels. That's probably good enough. So if you were just to run the multi-sample routine, but instead of actually ever writing to the multi-sample buffer, you just told me how many samples were covered, which you do, actually. I believe that is in the fragment shader. Is there any way to enable that and say, please render everything as if it was 16x multisample, but just don't actually waste the memory, because I don't care, right? Is it possible? Like, for example, if we were to turn on GL multisampling, but we didn't attach a buffer that actually had multisampling, would we get those? I really don't know. We don't care about any of this, by the way. Let's take a look at this multi-sample coverage. The ARP multi-sample extension provides a mechanism for anti-aliasing primitives. This mechanism allows an application to request an additional buffer. An application can request the number of samples per fragment, rendering blah blah blah. This install this single coverage sample anti-aliasing is an extension to multi-sample anti-aliasing. The technique separates samples into two samples. Color samples are samples with color depth and stencil. Information for the meta-sample where coverage samples includes both color samples and additional samples that only provide pixel coverage information. This extension follows the example of the NV frame buffer multi-sample coverage extension, which adds CSA support for frame buffer objects. The base description of multi-sample rendering is written in terms of coverage samples and color samples. The Windows System Notion of samples is layered on top. So this is interesting, and I've never read this before. Yeah, this doesn't quite look like it either. Mm-hmm. It's so close to being something we can use, and yet it keeps just slightly evading us. Why can't we get that information? Because it doesn't matter to that part of the pipeline, right? Like, there's absolutely no difference. Like, the part that invokes our fragment shader absolutely does not need to know that there is a backing store for the samples, right? All it's doing is taking n segment positions, 16 of them actually, and running the edge tests on all 16 and seeing which ones pass. That's all it's doing, right? And so we just need that information, which it could have just done. And if we can't get access to that information, we could do it ourselves, but man, that's a lot more work because now we have to pass that transformed version of the edge functions down into the rasterizing stage. So the fragment shader then has to do that. We have to do that in a fragment shader ourselves for those 16 samples. It just seems like they should be able to give that information to us because they were going to give it to us if we would just attach that buffer, right? I mean, the other thing that comes to mind that just sounds absolutely bananas is, can you attach a multi-sample and a non-multi-sample render target at the same time, right? Because that would be another way around this. We would attach a multi-sample buffer literally for no reason other than to force the shader to tell us what the information was, and then we wouldn't bother to write to the multi-sample buffer, right? That's another thing we could try. Again, it sounds absolutely ridiculous. Very frustrated right now. So is there any way we're not looking? Is there somewhere this could be that actually is in there and we're just not thinking it through, right? Let's do one more thing. Well, you know what? We could also even do it here too. But well, you know what? I'm going to do it in here. So if we go and we try to get like a header file, right? Like the glx.h or something like that, right? You know, this is a giant header file that in theory just has like every possible extension that you could possibly want in here as of like 2018, right? Hopefully. And so if I was going to search through here, let me just see if there's anything that sounds like it might be relevant. In terms of things we might be able to enable, we know what that one was. Didn't really help us. Those are the same versions, just arb. Again, not really. It gives us a lot of opportunities to go the other direction. So if, for example, we are in a multi-sampling mode and we want to take our alpha value and translate the alpha value into a coverage against the sample mask, that's available. But wait a second. That's sort of what we want, right? Fragment coverage to color. Get that up in the hot seat there. Let's keep on going. I'm not sure what a coverage modulation table would be, but this looks like some way of monkeying with the samples themselves. I don't see much here that looks like we probably care about it, though. We could read about that just for good measure. Um, I'm interested in this since I can't tell exactly what that's saying. I am a little bit interested to know what that is. So I want to get that one up there too. There might be something in there that we actually care about. I'm not 100% sure. So I'm going to check it out. Probably not. So this just looks like the standard stuff we use. I don't see anything in here that's specific to this. This is just for when we create textures that are multi-sample textures. So none of that looks interesting. So I will say this. This looks interesting. Is it this one? No, it's this one. This one looks interesting. I mean, both of them I want to read, but this one looks interesting. It basically says like whatever the well, that doesn't look that useful though, because the kind of way they did it looks a little bit different. So it looks like the fragment coverage won't come in as part of the shader necessarily there. Fragment coverage code is enabled or disabled with the generic enable. Yep. When disabled, skipped would enable the coverage treated as an integer bit field is substituted for the red component of one of the fragment color values. The fragment color value updated with the coverage mask is specified using this. Right. That works. Right? Like, it's kind of a wonky thing, but if we turned on conservative rasterization and this, that would work. That would do it, and then we wouldn't have to worry about multi-sampling at all anymore. Right? But I'm just assuming that this looks like some pre-shader stuff, right? Like, oh no, it's 2015. All right, so I don't know. Maybe, maybe not. Let's take a look at whether that exists anywhere, really. Um, so it kind of looks like basically these NVIDIA extensions just never got picked up. That's unfortunate. Yeah. I mean, I'll double check, but it's just looking grim here, folks. I think this is just going to be a sad episode. I don't really think there's much we can really do about that. It's really sad, too, because basically, like, we don't need anything other than just a little bit of information. Would be sufficient, but we just don't get to have it, unfortunately. And I'm not sure what to do about it. There's not like, there doesn't really seem to be much we could really do. Let's take a look at this extension here. Post-depth coverage. I mean, I guess another thing I don't really know is, does GL sample mask in just maybe just work even if you don't have multi-sampling? Let's take a look. Maybe there's some way to nudge it. So it says, yeah, unfortunately the docs just straight up right off the bat said GL sample mask in is a fragment language that indicates the set of samples covered by the primitive generating the fragment during multi-sample rasterization, which suggests to me that if we're not doing multi-sample rasterization, well, we probably just don't get a value. As the sample bit said, if and only if the sample is considered covered for this fragment, the array has seal S over 32 elements, where S is the maximum number of color samples supported by the implementation. Yeah. So I don't know, man. This, by the way, is what we're doing. Someone else on Stack Overflow already had to do it, apparently. Right? So, unfortunately, again, like, this is assuming that they actually want to use MSAA, which the entire point here is we don't, right? We don't actually want to do this. Because we don't need it. Once you have order independent transparency, you don't need MSAA. You just need the thing to do a conservative rasterization pass. This is really disheartening to me, because this is clearly the right way to do it, and I think the GPU could just do it. But unfortunately, it won't. And that's always what's so frustrating about GPUs. You know, I don't even think the chip probably would have a trouble doing what I'm saying. It's just you can't get at it, and so as a result, it doesn't actually help you, right? Well, that was a colossal waste of all of our times. So I guess I'm going to go ahead and say that I'm going to have to make a friend at NVIDIA and be like, hey man, why can't we have this? Is there a reason we don't have this? Why can't we have a Handmade Hero extension that's just like, when you turn on conservative rasterization, you can say to set the sample mask to like whatever the number of samples you want. Like, look, just pretend there's 16 samples. I don't care that there aren't. Just pretend that there are, you know? Like, what's it to you, man? That seems like the most sane thing to do, because I don't know what else to do. But really, there's no reason for our code to be doing stuff as crazy as it's doing. It really just does not need that, even a little bit. I should... Well, the render buffers, they're not going to help us. So really, we should spend the rest of this Handmade Hero like rendering a frowny face, because I'm pretty sure that we're just totally hung out to dry by our GPU friends here. I don't see any way to do the obvious thing that would be fast here, and unless I'm just not thinking of how to trick the graphics card into doing what we needed to do, it just, there's no way around this. We're forced to spend a tremendous amount of memory and bandwidth for absolutely no reason, just to smooth out these lines when our depth peel would have just worked. All right. So is there anything else? Is there anything I'm not thinking of? I don't think so. So yeah, I guess that's all pretty sad. So let's do one more thing while we're here. Wallowing in sadness. One other thing I did want to do that's, and I guess I shouldn't maybe be so disheartened because, now I think about it, maybe there is one kind of less good case there, which is that the triangles that form like the quad in question there, like, where the two triangles touch, if you don't use a multisample buffer, then how would you know that those two triangles are actually like coplanar and shouldn't have like a seam? So, like, I can sort of see why you might care about that part of it. At the same time, it does kind of seem to me like that's really not that big of a deal for us to fix because we know that they're always coplanar at that point. So, like, hey man, for optimization purposes, I still think we could have done a much better job there. But anyway, since I'm sad and I don't care anymore, I do want to do one more thing, which would be to say that when you look at how our depth peel is working currently, one thing that's not particularly good is if you look at the difference between these color passes, what you can see is that we are doing one thing that's fairly smart, right? Which is that we're doing our color passes in the order in which they would be seen by the viewer. So color pass number 1 is the things that are closest to us. Color pass number 2 are the things that are behind those things. Color pass number 3 is the things behind those things. And color pass 4, and so on, right? And so the only thing that I think we might want to change about this is if you think about what's going to happen as we add lighting in here, when you look at this and you think about how many lighting calculations are going to occur, well, they're going to occur for every pixel in the entire buffer, which may be fine. Maybe we subsample it, who knows? But point being, something happens here, and those lighting calculations are expensive. If we then go to this next one here, then what we would find is that actually a bunch of these things can't be seen. So if you look here, right, like a lot of the stuff that we depth peel away can't actually be seen. And by the time we get to here, most of it can't be seen, right? There are things that are just like too far behind other objects, and finally get to things that probably aren't seen at all. So the thing that's not good about that is that once we start to increase the pressure on the pixel shading by including all of these complicated lighting calculations, we're going to start to tank our frame rate by 4x because what's happening is we draw the entire screen and spend a ton of time lighting it, and then we draw the entire screen again and spend a ton of time lighting that, right? And that means that we're going to spend 4 times as much GPU resources lighting our scene than we actually needed to, because we only probably needed to light the things that are closest to you and maybe one thing behind that, but oftentimes not even that for many pixels in the scene, because most of the pixels of the scene are opaque, right? So one thing we might want to do is augment our actual color pass shader such that when you actually go to draw something, you only draw something if the previous pass didn't have something opaque in that slot. In other words, the alpha value that's actually in the slot, when you actually get there, if the alpha value that's in the slot that you would need, so, I draw the first pass and I've got a particular pixel, I know what both the depth value and the alpha value are for that pixel. When I go to render the thing behind it, if the alpha value was opaque, I don't want to render this thing at all, right? That's just fundamentally not what we want. Now, in order to do that literally as I just said it, we would have to read from the color buffer as well as the depth buffer, because the thing I just said was we need to see if the alpha value is opaque. But at the moment, we're only reading from the depth buffer. So one thing we could do is start reading from two buffers at the same time. When we do that render pass, we read from the depth buffer and the alpha buffer, and we see if both of them are what we need them to be. But with a little observation, I think we could easily figure out a way of not having to do that, but getting the effects as if we did. And what I think we could do is say, look, we know that what a depth peel does is on a depth peel, it reads from the depth buffer from the previous pass. And it says, I'm only going to render things that are further away from the viewer than what's in the depth buffer from the previous pass, thereby peeling away the scene one layer at a time. That's why it's called depth peeling. That's what it does. So what that means is that for any particular location on the screen, I can prevent anyone from drawing on any pass to that location by simply putting a value in the depth buffer that is further away from the camera than anything else could possibly be, which is basically the highest possible depth value or lowest possible depth value, depending on whether you want to think about things as getting higher as they go further away or lower as they get further away, right? But either, whatever way you think of it, whatever the one that represents things furthest from the camera, stick that value in, nothing will ever compare favorably to that, and so nothing will get drawn from then on, right? And that's an if statement we can do around the entire shader. Nothing at all needs to execute if that doesn't pass. And so what we could do is save all of that potentially expensive lighting calculations only for regions of the screen that actually have a 4x4 block that are actually going through that. Because remember, the if statement doesn't save us any time if we don't actually get all of the pixels in a little chunk to go through that same route of the if, because much like we did in our actually no, we didn't, did we? We used RGB, I think, so never mind. But point being, they work on sets of, say, 16 pixels at a time, sometimes more, and so if all 16 pixels don't go through the same path on an if, you don't really save any time. But for our case, because oftentimes they will, I think we'd save a considerable amount of time. Now, unfortunately, like I said, we're saving time in this place here that we don't really care about as much, but I think it's worth doing that anyway, because even though these numbers aren't high, they're about to get high as we start to increase the amount of work that the shader has to do that lighting. So if we wanted to do that, again, I think it's a pretty easy modification. We're in GPU land, so there are no real easy modifications. It's always more complicated than it needs to be. But it's at least one of the simpler of the hard modifications that you might want to make. And so if I pop over to our OpenGL, oops, that's the wrong one, OpenGL code here, what I'm going to want to do is I want to go ahead and look at our ZBias program. And that's not the one I want. All right. So here in the ZBias program where I'm doing this compilation, what you can see here is when I go through this particular section of the code, the fragment shader, which is the bottom one here, which has the lighting disabled at the moment because we haven't put in the full new lighting. What we're going to do is when we enter the main program, if it was a depth peel, you can see us doing a discard right away. And that discard operation will prevent anything else from occurring for the remainder of the shader. What that means is that I can pretty simply just add to this structure here anything that I might need to do. As long as I end up in this discard path, I won't pay any more cost if all of the pixels in a warp happen to go through that same path, right? So you can see here we've got a GL frag chord Z and a clip depth. The clip depth is the value that we're reading out of the depth sampler, which is the previous frame. The previous peel on this frame. What that means is that if we set this clip value to something, so here we got this GL frag chord.Z, right? and we're checking to see if it's less than the clip depth, right? If it's less than the clip depth, it will discard. What that means is that if we just set the clip depth to basically like the far clip plane, right? As far away as it can possibly be, we will discard everything, right? So all we really need to do is in here where we're going to write to the depth buffer, and don't ask me what that else discard is there. I guess it's probably for the alpha, huh? Yeah, you can see here we've got an alpha threshold where we just throw things away if they're too low. So the alpha threshold that we come up with, we then would discard here. We basically just need a similar one of these that will replace the depth value with something high in the case where the alpha value is really like very, very solid, right? So in here we would just need something like, look, if blend unit color A equals 1, right? So it's basically the highest possible one. There is no transparency whatsoever. If we want to just specify a fully opaque pixel at this point, then all we would have to do is basically say like whatever we write to the depth buffer here, which I believe is a constant we could just set in, I'm not a constant, a pre-named variable, I believe we can set in OpenGL. Whatever we want to write to the depth buffer here, we just need to make sure that it's very, very high, right? So something that would exceed pretty much all of our, anything that you would ever want to write to, right? So for example, if we look at our fogging here, right, we got our fog distance, our clip distance, all this stuff. We actually already have a bunch of information here, like our fog end distance that says where the fog cuts out, for example, right? So we kind of already know what this stuff is, and in theory, we may also, I don't know if we get access to the far clip plane, but we can actually just pass down an F32 here if we want to. However, in this case, I may say we just won't bother. Like maybe we just set this to some very high value and call it a day. Now, when we do a write depth buffer here, that's some nonsense I made up. We actually need to go look up what the GLSL output name is for the depth buffer. And in fact, actually, though, we already know that, actually, right? It's in here, isn't it? Don't we output to the depth buffer? Maybe, no, we don't. We only, because we don't need to keep it. Well, no, in the multisample resolve we would though, right? So in theory, we should have already had to have looked up what the heck you call it in the OpenGL nomenclature. So when we do the resolve, in here it should do it, right? So that, right? That's it right there. Yeah. So if we then go back to our compile z-bias program, in here if I basically just say, all right, when we are going to, excuse me, when we are going to write an opaque pixel, we also then tell the, we lie basically and say, look, pixel shader min, this is like this super far away value that we're going to put in here, right? We could do that. The problem with this approach, and why we'll have to do something one step more clever here, right, is that if I were to do it here, the problem we would have is our depth sorting wouldn't work anymore, because we're relying on that glfrag depth to be written properly in order to make our depth sort work for this peel itself. So I can't really do exactly that. But luckily for me, since we're already going through a multisample resolve, and of course we have to go through a multisample resolve because as it turns out, there doesn't seem to be any way to turn that off and still get smooth edges, even though I feel like we should have been able to do that, and I was very sad earlier. Inside the multisample resolve, we are done computing the fragment depths, right? This is the final fragment depth that we're actually going to use, and the final blend unit color we're actually going to use for that depth peel, which means that after we do whatever the heck actual stuff is we're going to do, right, and we go down to the end of the shader, I can, at that time, do it here, right? So if that blend unit color, the value that we're actually writing out there, is going to be fully opaque, then I can just set the GL frag depth to be something incredibly large, and that's the end of the game, right? So I think that should be all we really have to do. The only thing I'm not 100% sure about there is GL frag depth is, you know, probably ranges from -1 to 1, would have been my guess. So I'm thinking that really the maximum value wouldn't have to be in world space. It would probably only have to be in fragments, in clip space. So I'm thinking that probably 1.0 is a high enough value because that would be the maximum that you would ever hit, right? But I don't actually know, right? Like, I don't remember how we set this up. That's one of the problems of Handmade Hero being such little chunks over so long, is my brain doesn't really keep track of what we did, 6 months ago or something, right? And it has to page it back in, which is annoying. But point being, it's some value. Who knows how we set it up? It's a floating point depth buffer. I assume the values would be between -1 and 1. That may be an erroneous assumption. I don't know. I'm not a GPU guy. It's not my job. Anyway, so I'm going to see what happens in that circumstance, right? Can I basically blot out those pieces and stop having to spend time on things that really probably shouldn't have had time spent on them, right? So if I go ahead and launch, I'm not going to save the capture for any particular purpose. If I go ahead and launch here, the game still is rendering okay, so we can't have broken anything too catastrophically. And we can also see whether or not the depth sorting is working at all. I mean, it probably is because everything appears to be depth sorted properly. So again, I don't think we could probably have broken anything too badly. And the alpha's working there too. So let's suppose we hopped up on here. And then took one of those captures and just see, did I actually change anything, right? Because I don't know if I actually did. And then we look in on here. So there's that full screen. And here's what happens on the first color pass, exactly as I suggested previously when we were talking about how so much stuff gets covered. You can see that basically like the entire thing is almost completely opaque. Like there really isn't a lot of depth peeling going on here. Just some little stuff probably happening in there, but that's really basically it. So in this next pass, yeah, so this worked perfectly exactly as I hoped, right? So this next pass, you can see there's almost nothing rendered, and that's exactly what I wanted. We're only rendering pieces of the screen that actually needed to be rendered, which is pieces that were like behind some partially transparent piece, right? And then in the final one, you can see us getting even more into the minutia of things that were alpha on top of alpha. And then finally in the last one, there should be almost nothing, right? It would have to be like where multiple edges of multiple things intersected. And so that, again, has the potential of, it's not going to be much of a difference now. But if you look, excuse me, at these numbers in the future, since I can easily turn that piece of code on and off, I think as these numbers start to grow larger, I think we will start to see those become relevant, right? Now, there's another thing we could do, potentially. As I'm saying it, I'm not sure if we could actually do it, but point being that's exactly what I wanted to have happen, and hopefully you understand what I did there, right? It's pretty straightforward use of the shader resolve. So another thing we could consider doing there is if you look at how the resolve itself works, when we're resolving, what we're doing is we're reading we're basically blending values together, right? We're saying we're going to take in these values of these samples and we're going to blend them together and then we're going to output the results. That's the notion of a resolve, right? And the slow part of this is the fact that we have this if true here, right? So this if true, this is basically the thing that is saying, do I actually need to resolve this pixel? That's the thing I wish I could not have to do, right? If I set that to false, so we just don't do multisampling anymore, then what happens when I launch this application? No, I don't want to save this capture. And, you know, I do the nonsense here, get a look at what the timings, quote unquote, are, even though I don't really think they're that accurate. What you can see is just representative-wise, these draw array calls that don't, you know, everything's the same. We're still attaching a multisample buffer. We're still using multisample rendering. We're doing everything exactly the way that you would expect. So nothing has changed. All we're doing is that when we go to resolve it, we just don't read from it, right? We just take the first color sample and the other 15 never touched, right? Just that is if these timings are at all accurate, which we don't know if they are, but let's say that they were at least proportional, we saved like 10x, right? It's not 16x exactly, but it's close, right? It's getting up there. So you can see just how expensive that resolve was, and that prompts the question, is there some way that we could simulate that if statement? And even though we're not getting any help from the GPU here as much as we would like, is there something I could do that would solve this problem for us? And what you just saw was a good example of perhaps how that problem might be solved, right? There's two things we could do that would fix this, right? Thing number one would be, what if we just read from the previous depth peel when we do this resolve, and if in that slot the depth value suggests that we've already made this opaque, or we read the alpha value, let's say, so we basically know the alpha value, we're not going to use this value, then we just don't resolve it. Just leave it blank, right? I mean, we don't even need this. The else clause goes away, right? We literally just leave it garbage because no one's ever going to look at it, right? So that's one thing. And then the second thing we could do, and this is if we were feeling like a real saucy so-and-so, is we could try to construct a buffer that would have that information in it separately, right? And the way we would do that is what I was suggesting before. We would basically do one render of an actual multisampled target, resolve it, and then the only thing that we leave in the color channel is like a 1 or a 0 that is, should I blend this? Right? As I'm saying that, I don't think that actually works because you need to do it for every peel. So I take that back. That's not really true. Yeah, so I don't really think that that's accurate. I lied there. So the first one I think is true, right? And the second one is false, right? But I do think that, yeah, if we wanted to, right, we could say fetch the color or fetch the depth, our choice. But basically it would just look like this. Texel fetch from basically like a mask sampler. Same setup as everything else. And instead of sampling it multi-sampled, which we're doing with the other one, we would not. We would look at the alpha channel, and we would basically say, if the mask value that you see here is less than 1, right, then we know that we will actually be blending. So go ahead and compute whatever that value is, right? And then when you're done, write that out as normal. Otherwise, just don't do anything, right? Like this doesn't have to happen. So that's one thing we can do, right? And that would probably help us here. I want to say there's another thing we can do here, and we probably should, which is that while we're doing that, we should just build the output buffer, right? At the moment, we have this nonsense. Right? So at the moment, we've got this nonsense happening here, where we do a final full screen quad. We take four color samples, and we blend them together using their alpha values using this equation, right? So we take the final one, we then blend in the one on top of it, the one on top of that, and then the one on top of that, right? But actually, there's no reason why we would need to do that. I don't think. We could just treat it as an accumulator. Probably. I'll have to work out the math to see whether the coverage makes sense there or not. But honestly, like, you know, right? It seems like saving up 4 copies of the screen and then combining them with that equation. I mean, can't we just do it incrementally and only keep one buffer around? It kind of seems like it, right? And so I do feel like maybe this is a little bit long in the tooth, and we should probably get rid of that as well. So we'll think about that. Maybe that'll be Sunday. What I want to do now is, again, probably do that hookup that I just said. So basically, if I was to jump back to that Z-bias shader here, and we take a look at this. So when we go through here and, I'm sorry, not that. I meant the resolve. Where's that resolve? So if we go to compile, resolve, multisample. So really, I think, this does make a lot of sense. Let's fetch that mask, and let's only resolve these samples if we actually have to. It's not as good as what I would have wanted, which is some way of knowing whether we need to do this even on the first depth peel, but at least this might speed up the second, third, and fourth depth peels, and that's not nothing. Taking something that takes 4 times the time to taking just 1 times the time, hey man, that's a huge improvement, even though it's not the perfect improvement that I would have hoped for. It's not bad, right? So if I said here there was another sampler 2D for the mask sampler there, and we went to compile, peel, blah, 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 right? When we look at OpenGL, create program and link samplers, resolve multisample. I'm on the wrong one again. Too many samplers. Yeah, if you do OpenGL link samplers on this one, you can see here this is old news. We were even asking for some other ones here that we didn't actually even need. So that's kind of a waste of time there. But anyway, point being, we already had it set up to be doing more texture samples anyway, and now we actually will. So now we'll get the mask sampler out there. Now when we run this, we won't put anything in that channel, and so actually I think it won't do anything at first, because there won't be anything enabled in that texture channel. So at first, I want to say, and then maybe everything will just come crashing down now, but I want to say that at first, if I just run it without actually doing any work, that we should actually see just what no. So there is an error there. So it doesn't like the fact that we're not binding that mask sampler, I guess, or there's an error in this code, which may also be the case. So let's go ahead and run it under remedy so we can actually see what the error is, and I can read it and fix the code. So if I go in here and look at what they are, there's vertex errors. It's probably a fragment error, right? Because we weren't editing the vertex shader, so it's unlikely, right? But let's see what it says. Unfortunately, I don't think Remedy has a way to to do this, but it's on line 83. Unable to find compatible what? Unable to find compatible overloaded function. Ah, yes. Sorry. This is the fact that it's texel fetch, but that's not what we would actually use because texel fetch, I think, is only for sample index. So I don't think we want that, although we may still want it with just a texel fetch of 0. So let me see which one we actually want to use, because, yeah, okay, so no, we do. We just want to pass the 0, right? So we do want this. We want to sample at 0, which is, you know, the only one that texture has, because it's not a multi-sample texture. So let's try running it again. There we go. So now I'm not sure, again, whether or not we broke anything with that, because during that resolve now, we're looking at that mask value, and it's not guaranteed to actually be anything valid, right? So let's look in here and see what we're getting in terms of yeah, it's looking a little busted, right? I think. Like, I don't know why I'm getting some garbage in there. So I think it's a little busted, right? Which is what I would expect. And let me just verify that that's true. If I were to comment this out, right? So I were to say that this is just if one, right? And so we're not doing that mask test. We still do the fragment fetch, but we don't actually use it, right? Let me just verify that that actually produces... Oh, well, okay. Implicit cast. Sorry. If true. So if I run this again, just making sure again, I want to make sure that those artifacts are gone so that I wasn't... Are you serious? What is the problem? Syntax error. Unexpected $end at token EA. What the heck? What are you talking about? Can't just do if true? Did I accidentally insert some kind of garbage in there? Not sure what that's actually complaining about. I mean, correct me if I'm wrong, but all I did was change that part, right? So if I compile this, you're saying it's fine. Maybe it's not true. Is it some other thing? I thought it was true. I thought it was just TRUE was what it wanted. For those things. I'm not sure I see what the problem is there. So that works fine. But for some reason, that, like, doesn't work. I don't know. Anyway, I want to go see if those artifacts are still there. I'm just going to go ahead and here and just verify that they're not. And you can pretty much see that they're not. So I'm correct in thinking that that all seems to work just fine. And so now what we need to do is actually hook this up, this mask sampler here, and feed the color buffer in, for example, right? And so if we wanted to feed the color buffer in, what we'd need to be able to do here is do this only when we are actually depth filling is the only thing. And so that makes it a little bit trickier than normal because we wouldn't necessarily have a color buffer to feed this thing. But we might be able to trick that out, right? Because we'll see when we get there, when we're actually setting up our depth samples. I'm sorry, when actually setting up our peels, whether or not that actually happens. So let's take a look. Inside here where we've got begin peels, right? So you can see it setting up the color buffer there. Normally we clear it to 0, 0, 0. So we could actually also clear the resolve target and feed that in probably. Let's see. So when we do a resolve multisample here, right? So this is the one, right? And so when we bind the textures here, we bind the thing we're going to be sampling for the color. Excuse me. I'm sorry, for the depth, and then we do the color here. And we only, I don't know why we have multiple color channels at the moment, actually, because there should only be one probably, right? But yeah, so we only have the surface reflect. So this stuff was things for when we were doing fancier stuff, and we're not really doing that anymore. So we don't really have to worry about that. But basically what happens is we're going to bind the depth handle, then we're going to bind the color handle. And when you look back at the code there, where is my OpenGL? There we go. Resolve. When we look back at the code here, we want the color, the depth, and the mask. And honestly, the fact that these come in the opposite order, that doesn't make a lot of sense to me. I feel like the way these are bound is like depth and then color. And so the fact that they're opposite each other, I don't understand how that works, right? I guess they must be specified in the opposite order in the compile. Depth. So that's 0, 1, and yeah, they are. All right. So we should probably be a little more consistent there. So depth first, then color, then mask. Same here. Depth, color, mask. Okay. So in here, if we wanted to bind these, right, we would just do this. And in that texture slot there, we would want to put whatever came from the previous depth peel. So the previous depth peel's color, resolved color, is what we would put in here. And since we don't actually know that in the case of the first depth peel, because there isn't anything there, we would want to be able to stuff that value with something that wouldn't get looked up, or use a different shader depending on the circumstances, and depending on how we want to do it. But if we take a look at how this would work, we would end up in a circumstance where when we are doing this resolve here, we would want to bind the previous peel. So let's take a look at resolve multisample. So in here where we're going to be doing the peels, you can see us saying we're going to go from this thing to whichever one we're on, right? And what we want to do is say, well, in addition to that, we've also got the mask, and that's going to be this, right? But obviously, we don't always have that. So what we want to do is probably say, well, the mask buffer is going to have to be probably the 2 buffer itself, and we'll probably have to clear it in the case where we can't do this, right? So what we want to do here is say, look, if we're on peel index 0, so we're actually like just peeling the, we're doing the first render pass that isn't really a depth peel in the first place, then there's a couple of different things we could do, certainly, but the simplest possible one I would suspect is to just say, look, in that case, the mask is whatever we're going to, and we'll clear it, right? So that's what I would suspect we probably would want to do, right? in the case where we're not on the first depth peel, then the mask actually is a valid resolve buffer, and it's this one, right? It's the one that came prior. Now, the issue here, again, and, you know, honestly, maybe when I'm thinking about it, maybe we don't even want to do that. Maybe there's just a stuffing value that we throw in here, right? And the stuffing value, it's just always 0. So what we could do instead is say, yeah, okay, so in our OpenGL, right, where we've got whatever the heck happening here, we know we're going to have stuff like a standard texture that's just all white that we like stuff in there sometimes. And maybe we also want a texture we stuff in there that's like always all black, right? So we can basically just like pick when we don't really actually want to supply a legitimate texture to something. We can just have a solid color texture sitting around and we hand that instead, right? And so what that would look like is we just say, okay, there's a single pixel that's just all black, right? And maybe like maybe that. So it's not actually that it's black with a 1 in the alpha channel. It's actually all zeros. So it's really no color at all, right? It's like completely not there. It's invisible, right? And we just set that mask up and then feed that in and run the resolve multisample as normal, right? I think that's all we would really need to do. And so it's not too bad. If we look, I don't know whether we've actually got this in our bindings currently to create some textures like that, but it's not too hard for us to do either way. And so if I look, I'm not sure. So here's in the init function, right? And you can see that here doing this, creating this sort of white value to pass down. Just don't know if anyone actually ever uses it, but it's basically what we want to do for the all zeros value, right? So what we would want to do there is like, yeah, again, to prepare that texture. I don't really see much we can do there, but so let's just do this, right? Or just have an all zeros value. We say, look, give me one of these things. What did I call it again? So we have one of these things. We generate one of these single pixel all zeros texture, right? We then do a text image 2D, and we just say like, look, this thing is just going to be this all zeros, right? And so it's going to be a 1 by 1. I don't really remember the parameters of GL text image 2D. You know, sue me. Oh, it's right there. No. So we pretty much don't ever call that, do we? Let me take a look. All right. So if I just go ahead and, oops. If I just go ahead and submit this one down, right? So we know it's a GL texture 2D. I don't know what the format is, so we'll have to go look that up. But the width and the height are 1. It's, you know, the same as everything else we go down, but it doesn't really matter. So we could just use this and leave it at that. And then we just pass it all zeros, right? And so then all we really need to do is just fill this out. And so I can actually look at what we were filling that out as well, so I don't actually have to look at the GL documentation. So that format value here is what passed in. Must be kind of coming. There it is. So when we do frame buffer text image, just glRGB8 probably, right? So that would create that special texture for us. So it would do a gen textures to get one, and I'll need to actually put that in here. So there's just a, glue int for that. So we'd generate the textures, and we'd have a happy times for that. Oh, and this bind texture here just needs to actually have mask. It's not a frame buffer per se, though, right? Or is it? Yeah, so we actually want to pass the specific color handle. So what I actually want here is I want this. So I really just want to bind that mask texture directly. And then when we call resolve multisample, I'm either going to pass it the color handle of the frame buffer that we actually used, or, I'll... yeah, and these are the multisample buffers, right, too? So this... we actually don't even want that. I just want the depth peel buffers, right? So I just want the depth peel resolve buffer. And in that case, I guess they just don't have those filled in. But either way. So in here where we get the mask, it's not that, right? It's actually this. Right? Something like this. And so then we're saying, look, just stuff it normally, and I gotta actually pass the mask. Stuff it normally with just, whatever the previous color channel was. And then in circumstances where we don't have a previous channel because it's the first depth peel, fill it in with all zeros. Right? So we can see if that does anything good. It might not. But we'll see in a second. Let's see first if we're getting any actual artifacts here. Can't quite tell. I'm not convinced yet that I didn't break it. I think it's still broken. I feel like that's not quite right. Yeah, I'm definitely seeing a few artifacts in there. So I think it was a valiant effort, but we're still a little bit off, right? Just a little bit. But we're close. Anyway, if we actually take a look at what happens now, where we're passing in a mask value, and we use the mask value to determine whether or not we should blend, we set that mask value in such a way that we at least hope that the alpha channel tells us what we actually need to know. And in fact, if we look here, we can also see, let me just verify in resolve multisample. Let me just verify, yeah, we're using from color handle. This is when we do an OpenGL begin screen fill, it's going to use that frame buffer, and that frame buffer would only have just the color buffer, if I'm not mistaken. So I think that's fine. So let's take a quick look at that in RenderDoc, and then we'll call it a day. But I think we do have a bug in there, so I'm going to have to be a little bit more careful and look through that with more... Oh. Sorry, RenderDoc. All right. So now looking through here, I just want to verify that it does what I think it should do. And let's see. So Yeah, not really. So these are kind of semi-nonsensical results that I'm looking at here. All right, so when we first do this, it looks like the mask is never succeeding. Did I like screw up that change? I don't know. We can look and see if I screwed it up. If mask is less than 1 from the thing that you put. Well, so, I mean, correct me if I'm wrong, but if I had actually succeeded in stuffing it with all zeros, then this mask value should always be less than 1, right? It should always be 0, because no matter where you sample it or what channel you pull, you're always going to get 0, right? So that seems a little odd to me. But let's keep going. So if I were to look at this particular pass, we know this is probably correct because we haven't touched the color pass. We look at the draw erase pass. I just want to know what went in here, right? So what am I actually getting? Well, that was kind of a nice little mesh view there. Anyway, what am I actually getting when I look at the fragment shader? What's coming in here, right? And so if I look at the depth sampler, I can't actually tell. That's what I expect to see here. I'm not sure why I don't see a depth buffer properly. But maybe I've got these things bound backwards. That would make a lot of sense, right? Let's look at the mask. I'm not sure how to use RenderDoc really. Like, I don't know how to look at these things. So texture 51, like shouldn't there be some that says like how big it is? I guess that 1 by 1 is the thing. 0 by 0. 0 by 0 doesn't seem right. So that seems a bit bad. Okay. Let's take a look at the color sampler if I'm doing this right. That's what we would expect to see there. And then finally, the depth sampler. Oh, you know what? I'm clicking the wrong button. That. There it is. Okay. Those all look correct. The only thing that looks busted to me is I don't understand what I'm looking at there. I may have submitted this texture wrong. So let's take a look. It's easy to do that. It's probably just some typo nonsense. So, oh, yeah. Fantastic. So that may be the only problem there. Oops. All right. So let's see if that's any better, because what I was doing is I wasn't actually initializing that texture. I accidentally set the wrong value there. So let's try that one more time. See if this changes the perceived results here at all. All right. So if I go up here like I was doing before and kind of look at one of those edges, see what I can see, and it again, it doesn't look right. I'm getting like leakage there, I think. So I still think we're not getting it, right? Maybe we're a little closer, but not right. Oh, you know what? I do want to debug that though, because that was very handy. So let's take a screenshot there. F12, and then close it. So looking through here, let's take a look at this pass again, right? And so here's the first drawing, color pass. Here's the draw erase. You'll notice this time it's not all black, so it looks like it did properly pass, right, to me. So that's good, right? You can see that resolve. And you can see furthermore that it looks like it did anti-alias properly, right? So the first pass now looks good. It was busted before. It looks like it's less busted now. The second pass, as you might expect, is rendering kind of where we would, I guess, expect it to, because that's where two primitives are meeting and fighting for supremacy, potentially, right? I don't want to know why that's purple, but maybe it's a lighting probe. And then when we draw a race here, we're actually resolving it. That seems like it could be fine. I mean, I don't know that there's anything particularly wrong with that. What I would say is it looks like the depth is... Yes. We do need to save the depth buffer. Yes. Because it needs to go into the resolve for the depth peel. So we do need to write one piece of information in there, which is to say that because we're not rendering the same depth buffer every time, we do need to, when this doesn't work, we do need to at least write out the depth. That does have to happen. So when we do this else, we do want to do that. I don't know that we really need to output a color, because if we're not going to use this color, we probably don't need it. And technically we don't need a frag depth either, so these fetches probably aren't necessary. So I want to say we can probably do this, right? And then just set the GL frag depth to be like stop, right? Don't depth peel anymore. I think that might be a little more correct. Let's find out. So if I now go to the launch and get this going here, no, I don't want to save the capture. Uh-oh. That's probably just us crashing and not having set this correct. We probably don't write to blend unit color. All right. So we need to write something to the blend unit here, probably, I would guess, just to avoid any issues. So we probably need to write some black channel out. We could change it to like a purple as well so we can see it, but, you know, either or. So we do need to write something to the blend unit color, probably, I'm guessing, or the compile will fail. We can go look and see if that's actually it. Maybe that wasn't it. There we go. Let's take a look. Syntax error, unexpected end at token. It keeps giving me that. What is it talking about? I have no idea what it's actually complaining about there. Like, none at all. It seems like very unhappy, but I'm not sure about what. So let's suppose we just did this. See if that makes it any more happy. I don't actually know. I really don't know if that's part of the problem of just like embedding this thing in the code if it's getting confused or something, but I don't see what it's objecting to because the code looks fine, right? Like, I don't see... I mean, we didn't do really anything. Maybe we get rid of a couple of these cases here. But I want to keep that multi-sampling debug in there. You know, I would like that to remain in there. Yeah, I really just don't see what the crime is, right? So basically what you're telling me is previously we had this, and that was fine. Right, like everyone loves that. No one has any problem with that. That's fantastic. The shader compiler's like, yes, really good. How's that? And that's fine. Everyone loves that. Everyone thinks that's really good. That should also have fixed the bug, by the way. So meaning I would have expected that too. But that actually doesn't look like it did. Weird. That's a little disheartening. Excuse me. But then apparently, like, if you commented those out, that would be like horrible. Like you definitely can't do that or something. Nope, still okay. I have no idea what this is doing. I have no idea why it didn't like this. Alright, well, I don't know. And I don't want to know. I'm just going to set the frag depth to 1. And since that seems to be okay, who knows? Maybe we'll have to do something a little fancier there with how we're... Oops. With how we're submitting shaders so that we can put them in separate files. I don't know. But anyway. I would have thought that writing the fragment depth there would have solved the problem. But it didn't solve the problem. And so that suggests to me that I'm not quite sure still what is wrong. I've got it wrong. I've got it wrong in my head, not just in the app. So if I take a look at this, right, again, that looks like a pretty good resolve there, kind of what I would expect. There's the initial pass. These are multi-samples here. If I then do this resolve, I expect it to get smooth, right, and it does. Now if I do this, I expect to see places only where primitives overlap. I'm not 100% sure that that's okay, but I think it probably is because those primitives do occupy potentially the same location, right? And so then when that resolves, we get that. Then when we do the next pass, yeah, I don't know. I don't know why we're really getting those cracks. Let's take a look at that if I don't use the mask input, right? But by the way, also when we look at this here, if I actually try to analyze what the speed is like, I'm not sure if these are actually representative. Actually, looking at that, it looks kind of semi-nonsensical, actually. But anyway, if you believe this wildly now different set of numbers, possibly because we moved the camera though, you can see that the original resolve is expensive. These are considerably less so, right? And yet that one is very expensive, and I have no idea why. Like that doesn't make a lot of sense either, does it? So I don't know. We're still a little bit busted here. We're kind of over time, so I should probably wrap it up. But point being, I do think we should probably go ahead and push forward on that and make sure we get that working. Because I do think it would be fairly substantial savings. Again, if you just change this to always being true, So basically this, which of course it probably just complained that for some reason now we've written a completely ridiculous shader that doesn't work. But if we just set that to always being true, when we run the application, no thank you. That is so frustrating. Is that a problem with forecoder or a problem with... I don't know what that's a problem with. Like, it really just doesn't make any sense. How about that? We have not had this problem before. I wonder if it's because of virtual white space, actually. In forecoder, I'm not sure. But we can take a look. Yeah, I mean, that's just garbage. I mean, that's just total garbage. So I don't really know what to make of that. It could be because of virtual white space. I'm not really sure. It's super annoying and really stupid and the kind of thing that I hate about developing software ever, because it's like, this should not be something that I ever have to think about when I'm actually working. And yet it's like 50% of what I have to think about. So I just want to switch this off for a second and leave it that way, because I'd rather come back to it tomorrow knowing that it wasn't broken in some other way, right? That seems to be a hugely impossible thing to ask of C and or forecoder. I don't know. Or perhaps just OpenGL. So I'm not sure why I can't. You know, it could be that if I changed these, let's just hypothesize here. If I changed all of these comments to only be comments that were C style, then maybe it, since it doesn't matter where the line breaks are at that point, maybe that works. Because it could be that what it was doing was interpreting those comments as going longer than they should have gone. You know what I mean? So I'm wondering if I just do this. Does that solve the problem? Nope. So yeah, I mean, I have no idea what it doesn't like. It doesn't really make any sense to me. It could be, again, pound defines probably wouldn't work either in that case, or pound ifs as well. So if it was getting confused about where the line breaks are for some reason, that could be. What I could do is look at what the code is actually on disk. That's probably a good idea. So if I come into Remedy, let's see what Remedy thinks that parse is like, because it's not using the virtual white space thing. So if I actually went into that code, shouldn't I? Oh, whoops, I spelled it wrong. Where did I get? How come I couldn't actually get in there? Oh, duh. It probably just inlined it. No worries, I'll just look at it this way. So here's compile resolve multisample as it was written to disk. Here's the fragment code, right? You know, it looks normal to me for pretty much all intents and purposes. It doesn't look like 4Coder's doing anything weird there to me. The error output by the shader compiler is horrible. Like, it doesn't tell you at all what's going on. So I'm not sure. I'm grumpy, but I'm not sure. So I don't know. I also did that and it didn't work. I don't know what's going on there. I really don't. That's extremely frustrating and it makes developing this almost impossible. So I'm going to have to, I guess that's what we're actually doing Sunday, since there's no chance I can possibly keep going with it just randomly failing like that for no reason. But I guess that's where we're at. So if I go through here, and when we do the textile fetch, I just need some way of nerfing just this one line, right? And so what I was trying to do before is say, well, I would like to set mask. You know, maybe I just do it without a carriage return. I don't know. I would like to set mask to 0 if possible. You know, just to make sure that it still works if I do that. Whew. All right, and so then if I look in here, I'm just curious, does there still have a bug? So the bug is still there, even with that not happening. So maybe it's a little overblown. Maybe this happens always. So if I was to remove that code entirely, like we're just not doing that anymore. So it always does the full the full resolve and there's no checking whatsoever, right? We just have that bug. Like we've had that bug for the entire time, apparently. And it just doesn't really matter because you have to like get up so close to see it or something. It does appear, right? Like it's there. So I don't know. Unless we just introduce that in some other way, it does look like actually this just worked. So I guess I can't leave that in because it looks like that I didn't actually introduce a bug. Now I still would want to be a little more careful about that. But it does look like, on the whole, I don't know. I'm seeing artifacts that I didn't see before, though, so I'm not willing to believe that yet. I still feel like we've got issues. Here's it back where it's just doing the composite at all times. And you know, I don't see anything. Everything looks nice and smooth. So I don't see any artifacts there. Put this back in. You know what those are? You know what artifacts I actually am seeing? It's just actually anisotropic filtering on the bitmaps. That's what I was actually seeing, which is new, relatively speaking, because we only added bitmaps recently. Probably have to fix those. All right, so maybe there weren't any. All right, so if we do actually now, finally, run the game one more time, do the capture, close it, and look at the timings. Now we can see we've done a pretty good job. It's not fabulous for these two, it looks like. So maybe there's some... Yes. So we almost finished, but not quite. We really were able to make this be almost free, right? Which is great. So, but the other ones are not free. So this one and this one. Why? Because they're not reading from the correct place, really. This textile fetch is it's gonna be whatever this alpha value comes back as, right? But we're not writing out a alpha value that would indicate for the next depth peel. When we block it, we're not plugging up the value for that depth peel, right? So what we actually want to do is when we know we're completely occluded, we want to set our blend unit color as well. We want to set that to have an alpha value of 1, right? So we want that is what I think we actually want to do, right? Now, of course, I won't be able to do that because, heaven forfend, I'm able to compile a shader in 2019. But that's what we actually needed, right? And so I think that now, if we actually take a look at that through via render doc as a performance profile, now I think we'd see a pretty good improvement there, right? So now if we take a look at the actual times, like now you can see these things are minimal, right? This first resolve is hugely expensive, but all the rest of these are almost free, right? And we haven't really given anything up, I don't think. I think we maintained all of our quality, basically. And man, just look at how much freer that is, right? Like our render time went down by a factor of almost 4, right? So that's really, really good. And I'm pretty excited about that. And I think we are still at exactly as high a quality as we were. But now we just take drastically less GPU time to do it. Know what I'm saying? And let's just double check rather. Double check, yeah. Let's just verify that everything's still kicking. Seems to be just fine. So that's good. So not bad for, you know, like, we didn't quite get what I wanted, which is to not have to use multisampling at all. But hey, our multisampling is now really, really cheap, which is about the next best thing, right? And I don't see any artifacts in here other than maybe some MIP mapping problems. We probably need some anisotropic on those really steep walls, but other than that, I think we're good to go. Oh, am I exceeding the size of the buffer? I could be. Let's find out. I should have actually said we're going Q&A, but hold on a second. Fragment code. So if this is like 4,000 something, then maybe. Yeah, that's gonna get optimized out. Let's just do it this way. It's close enough. I mean, it could be, right? I would be willing to bet that. It's a good guess. Unfortunately, I don't quite remember exactly how much was in there, but yeah, maybe with that comment in there, right? So like, yeah. Again, I really wish, like, it's nuts that I have to do any of this. It's ridiculous. It's just, for some unknown reason, and I don't know what the reason is, we can't seem to get past the fact that we have all these different compilers. Like, all I really want is to just have this in my code, right? But instead I've got all this janky, it's like super janky how these things are going through. I'm not surprised we hit that. And there's really not much I'm going to probably do about that either. Because it would, you know, again, it's just a pain. And I also can't even read these things, right? Because they're like not formatted properly, because they're formatted as if they're a string. It's just, it sucks, right? But I don't know. Short of actually having a more developed environment, I don't know that there's really much more I can do, right? Because it's like, the next step, which is the correct step, is to be able to just write the shaders directly into your program as code. And then when the compiler pass goes over it, it extracts those out using all of the correct pound defines from your standard build and everything, and they just go into the shader instead of going into your actual executable, right? But that's something I can build, like, you know, when I'm doing a full code base. But on Handmade Hero, I just have to use the crappy tools I have, right? And so, is this a good way to do it? No. Do I want to build out the correct solution? No, because we just don't have that kind of time. You know what I'm saying? So, unfortunately, I think we probably just keep stumbling along on it. But thanks for the catch, because I was like, what the heck is going on there? I guess 4096 isn't as big as I thought it was. That's crazy that that's a 4K shader. But it is. Makes you appreciate why shipping shaders as source is not great either, right? Because that's actually 4K and it hardly does anything. All right, so we have 0 questions, it looks like. And that makes it easy. Couldn't you just not? Oh, no. I mean, that would be nice, right? But the problem is that we actually stick crap in there. So, like, we actually dump in the max multisample count. And so, unfortunately, we have to specify a size ahead of time. Again, this is stuff that is just because of the limitations of the crappy language that we use, but, you know. Why can't you just run the preprocessor on the shaders, though? Well, I can't. Like, so there's a couple things I could do, right? But again, there's really no way to do this kind of operation. So what you want is you want this sort of stuff to be... What you want to be able to do is you want to be able to do something like, let me go through all of the max multisample counts I might use. Let me compile all of this shader multiple times into multiple buckets, and then pick the right one based on that. That would be very easy to do in a metaprogramming environment, right? Like it'd just be trivial, really. But the way that modern like C++ and stuff works, they don't have any of these abilities in them. So as a result, what we're doing is we have to basically do a printf or, choose any other string operation to produce the fragment code and insert dynamically at runtime which one of these settings happens to be true, right? So as a result, we have to pick how big the thing is going to be, even though we really don't need that, because technically what we could do, technically this is just going to a shader compiler, right? Which unfortunately we don't have access to. But even if you were like going to use an intermediate representation or something, right? Then there would be no need for any of this because you could already the compiler could already have taken all of that and converted it to the tokens, and then all we would be doing is replacing a constant in there with the constants we wanted, right? But none of that is on the table because like development systems are so far from being anywhere near being able to do that we just have to kind of like clunk this stuff together. And it's not good. And if you really wanted to solve the problem well, you wouldn't do what I'm doing here, right? But you always have to make a trade-off. Like, am I going to spend a bunch, like several weeks making this system that does all of these fancy things, or am I just going to get by with having to deal with the occasional bug because like this buffer gets truncated or something, right? Now that I know what that error is, I'll just know to increase the buffer size. But I could not tell. It was very confusing what it was trying to tell me, right? It was a little too cryptic. Let me try to see if there's any other questions. All right, so I think that's it. Do you have any concept of a string builder that you could use with your format string function to have it pass you back a string allocated from temp memory? It's a small thing, but you wouldn't need to worry about that anymore. I do have that when I'm actually programming, like in my code base. We don't have that on Handmade Hero. We probably could make one without too much time because we do have a streaming buffer. Like we do have this, right? So we could probably do that, maybe. But again, it's just probably not worth the time to make it, right? Because we don't really do this anywhere. This would be the only place it would get used. So let's see. Someone was suggesting dual depth peeling. They have not enabled multisampling, however, I think it's possible to work. But what we were working with was specifically multisampling. I'm not sure. I can look at it though. Is this it? SDK 10 OpenGL screenshots samples. Yes. We can just take a look. Let's see. Yeah, so that does sound at least interesting. Just trying to reduce the number of depth peel passes. I'm not sure. I have to see what they actually do here, though. So here's the money part. We solve this issue by working on a sliding window of 2 consecutive layers. I'm not sure what that means. We essentially turn off the hardware depth buffer and use blending to perform the read, modify, write part of our custom depth test. The peeled fragments from the front layers need to get... I'm less enthusiastic about that, though. Because that may get off certain fast paths that are about depth testing. Is the only thing. I mean, maybe it's fine. So yeah, I'm not sure about this. I would have to digest it a little bit more and think about whether there's anything from here that I particularly wanted. But I'm not sure. I'm not sure. Um, I get what they're saying, but I'm a little nervous about the fact that it's not using hardware depth testing. I would want to hear from somebody who actually did the performance profiling on a modern hardware card that was okay before I actually spent the time to implement that. You know what I'm saying? So I don't know. I don't know how I feel about that. Have you considered using RenderDoc directly to recompile the shaders at runtime during rapid development? Um, I haven't really, but I probably should. Uh, we can actually recompile the shaders, I think, ourselves on the fly. Like, in other words, the act of recompiling them in the game is pretty easy. I think we can just do that. Like if I go in here and want to change the color of something, like, you know, I think we just can. And then when you recompile the game, I think it reloads. Maybe it doesn't. Oh, you know what? It might not, because we don't reload the graphics driver anymore. It used to do that, but I guess we don't anymore. So that might be helpful. We could also just re-enable that, meaning re-enable the ability to reload the graphics driver at whenever it changes. We just don't do that in the platform layer right now. So I don't know which of those two things I'd rather do. We haven't spent that much time working on these at the moment, so it's not that bad. But when we do the lighting, that may be helpful. So it's hard to say. You know what I mean? Hi, Casey. Some episodes ago, you said you didn't understand why John credited you on Braid, since you didn't do any work on it. Well, no, that wasn't what I said, or at least, hopefully, that wasn't what I said. I mean, you can go check the video. What I said was, I'm not sure why I was credited so prominently. In fact, I specifically think I said it would have made more sense if I was just listed as like additional programming or something. But instead, I got listed like as a special section, like right at the beginning of the credits, that was like Rewind Evangelist very prominently. And while it's certainly nice of John to give me credit for something, it really probably wasn't super earned, is all, because I didn't um, come up with any of the design for Braid. I was he said that because of a mailing list post I'd made that was just talking about how the player's time is valuable, and so if you're going to make them do something a second time, you should make it be worthwhile. And games that aren't going to do that should just have rewind, so I can just like correct my mistake and move on, right? Because that just seemed natural to me. So he gave me credit in the game because of that mail, but the mail was just complaining about something else, right? So it was really the entire idea was John's idea, not mine. It's sort of like if you gave someone credit for a game you wrote because like you thought of the game idea after reading like a short story or something, even though that short story does not appear in the game, you know? And so it's kind of just like giving me credit as being a source of inspiration for something, which again is very generous. It's just probably not deserved. It's like if you actually were there and saw the connection, it was very tenuous, and the entire like goodness that came out of it was because of John having a whole suite of ideas that really weren't contained in that mail, and honestly were very tangentially related to that mail. You know what I mean? So again, love to have the credit, and it's super nice of someone to go out of their way to credit you, especially in a circumstance like that where you really don't deserve it, you know? But that's why when someone was asking me, I think they asked me why I was credited as Rewind Evangelist. I was just trying to be honest by saying, like, if to be frank, like really honestly, the only thing that I contributed to Braid was the like code for rounded rectangle collision detection. And it was because John was like, I happened to be sitting at the same table as him with laptops out one time, and he was just like, "This is stupid. The thing that's in here, it's not smooth. I'm gonna replace it with something good." And I was like, "Oh, I've got this like one file, like this, you know, literally just one file that's a rounded rectangle overlap tester. You know, that'll give you the rounded rectangles you want. Go for it, right?" That was the sum total of like my contribution to Braid. You know, that and playing the game in beta. But I don't even really know if I don't remember what feedback I had on the game, but I don't actually think I really had any valuable feedback either. So it was like, it was the level of billing I got in Braid versus the level of contribution in Braid are not related. I got much higher billing than my contribution by far. How would you implement in debug systems the way of changing also v3 v4 values? Don't we we have that, don't we? Though, don't we have a thing that adds v, like we have that in like the like placement editor, right? I just watched the video about subpixel sampling for pixel art assets. Thank you for explaining it. It was really good. I have two related questions though. When you viewed the sprite sheet, you noticed that it's not alpha pre-multiplied and kind of mentioned that it might be a problem. I was wondering why. The reason why is because pre-multiplied alpha is the only way to make sprites sample properly using bilinear filtering. Using hardware bilinear filtering. Or maybe I should say the default way that hardware does bilinear filtering. So if you have non-pre-multiplied alpha, then your bilinear filtering will be wrong unless you actually pre-multiply first and then bilinear filter, right? And so all I was saying is that using bilinear fetch won't work at the places where the alpha is not 1 or 0. And so they kind of set us up for failure. Even if we had been able to replace the shader, we would have got some black fringing around the edges of things when we tried to use bilinear to filter. That's all. As for number 2, which is you mentioned that they don't use MIP maps, and you're saying, how should we produce MIPs for pixel art assets? Box filtering would not work since it's made for bilinear. So I guess what I would say there is just that when you're making something, when you're minifying something like that, so you're taking something that was previously, that would be when you shrunk it all the way down so that your pixel art is 1 pixel per screen pixel, 1 texel per screen pixel, right? So when you do that, what ends up happening is by the time you've gotten down there, when you want to shrink it smaller, bilinear is probably fine. Because the pixel art is too small at that point to look like pixel art anyway, so it probably should just bilinear filter. So minification filter is fine, I think. It should be just fine. Magnification filter is the only time when you can't just turn on bilinear and forget, right? So the mipmap should just be fine, I think. And I guess I haven't thought about it too hard, but you may need to put an if in the shader that just says, look, if I'm minifying, don't just do regular bilinear and forget about it, right? Zero he says, you're right, but I think you need shaders to have point sampling. Yeah, so for point sampling, then you don't have to worry about it, right? So the reason that they don't also have pre-multiplied alpha, the reason why they don't also have black fringing on their sprites, in addition to all the other visual bugs they have, is because since they're not properly filtering using any kind of blending, they don't have to worry about the fact that they're not pre-multiplied alpha. But once you actually do the correct blending for pixel art, you are using the bilinear hardware. You're not just using it the same way you would be if you didn't adjust your UV coordinates, but you are using it, right? And at that point, you have to then, again, make sure you're using pre-multiplied alpha, because if you don't, then bilinear filtering doesn't work, right? I mean, it works, but it produces subtly wrong results. The alpha is not correct, right? Sirius says, thank you, Rich, for the skin mesh video. I still have to watch it. What? You haven't watched it yet? I specifically made that video for you. You have to go watch it. Go watch it. All right, that's it for questions. It's time for bed. What's the problem here? Did I accidentally insert something? I didn't think I did. All right. Thank you, everyone, for joining me for the episode of Handmade Hero. It's a pleasure coding with you, as always. If you would like to follow along with the source code at home, you can always pre-order the game on handmadehero.org, and it comes with the source code right away, so you can play around with it even while it's still in development. Again, as I mentioned at the beginning, we now have a Discord as well. I'm probably going to put some links on here so you can click and go directly to it. But while we're still working out the kinks, if you do want to check it out, It's just discord.gg/mollyrocket, and that'll go straight to our Discord. If you're on Discord, check it out. There's plenty of fun discussion that seems to be going on there. It's been pretty good so far. So give that a little look-see if you're interested in chatting about the series or game development related things, or just interested in checking out some of our other projects that we've got in the pipeline at Molly Rocket. That's it for today. I'll be back here on Sunday I guess at that point, we've pretty much done everything we needed to do. So I think at that point, maybe we don't really need to do anything other than finish up the turning on like ground cover and getting that flowing faster through the pipeline. And then we've got a pretty good performance-oriented profile on our GPU, at least for this stage of development, I think, certainly. So I think then we're good to dump lighting in there and see how much worse it gets. All right, that's about it for today. I'll see you back here on Sunday. Until then, have fun programming, and I'll see everyone on the internet. Take it easy, everybody.